Okay, so we're continuing to talk about solving a system of linear equations, and this is going to be part 2, and this is going to be substitution. Now remember, the whole idea behind solving a system of linear equation, behind solving a system, is to find the solution. In this case, the solution is going to be an ordered pair x, y, because they're two variables, so that when you substitute those x and y values into your equations, both equations are true at the same time. So that solution has to satisfy this equation and this equation in order for it to be a solution to this system. All right, now remember in the previous lesson, you saw that when you graph these linear equations, the point of intersection is the solution. So the part where the graphs intersect is the solution. Now when we graph these, remember when you graph these, you have to be very precise when you graph these because if it didn't lie, if the intersection did not lie on a grid, if the intersection did not lie on a grid, then it was more difficult to determine the solution because you had to estimate. So graphing is not the most efficient way of solving a system. So you really want to solve a system algebraically. You want to solve a system algebraically, and the way to do that is to use substitution or the addition method, which we'll do in the next lesson. So the more efficient way to solve a system is through substitution or the addition method, which we'll learn. Okay, so let's talk about substitution. Let's do this by substitution. All right, so there are some steps that you're going to use to solve a system using substitution. So one of your handouts on section 8.1, one of your handouts has this in it. So solving a system, a linear system by substitution. Step 1 says this: solve either of the equations for one variable in terms of another. So basically, either get the y variable by itself or the x variable by itself in one of the equations. Doesn't matter which one. All right, but what you want to do is whichever one you use, you want to make sure that the coefficient of x is 1. So for example, if you were to choose, let's say, the second equation and you solve for x, you would have had to divide both sides by 3, which would have introduced a fraction. So you don't want to deal with fractions. Don't deal with fractions. It makes things a lot more complicated. So when you're dealing with substitution, don't deal with fractions. All right, so whatever variable you get by itself, make sure there are no fractions involved. Okay, so again, let's go back to step 1. We're going to pick an equation. And we're going to get the variable by itself. All right, now it says this: if one of the equations is already in this form, you can skip this step. So in other words, if you look at this, at equation 1, in equation 1, is one of the variables already by itself? And the answer is no, because x and y are both on the same side. They're both on the left side. But if you look at equation 2, and it has the same question, is one of the variables by itself? The answer is yes, because y is by itself. Now x is not, because there's a coefficient of 3 there, but y is already by itself. So in step 1, I'm just going to say we will use the equation y equals 3x. All right, so I'm going to use this equation. All right, so that's the one I'm going to pick. I'm going to choose, I'm going to use this equation. Y is already by itself. Okay, y is already by itself. Okay, now step 2. Now listen carefully to step 2. All right, so remember I chose this equation. All right, so I chose that equation. So the only equation that's left that I've got to deal with is the top one. All right, so step 2 says this. Step 2 says you're going to substitute the expression found in step 1 into the other equation. All right, so you're going to substitute the expression found in step 1. So here's my step 1. Now remember, this is y, so y is by itself. So look at the other side. So that's the expression they're talking about. So underline if you need to. Underline the other side. So you're going to go back to the other equation. Notice they use the word other equation. You go back to the other equation. Okay, the other equation. And remember, you solve for y. So in place of y, so if you need to draw this, you need to draw this. Go ahead and draw this. So in place of y, you're going to substitute 3x. You're going to substitute that expression into the other equation. So look at what we get. We get x plus y. All right, your y now is this. It's 3x. You're going to substitute 3x equal 4. So remember, your other equation was this. So x plus y, and remember y is 3x, equal 4. So now you have an equation with just one variable. You now have an equation with one variable. So that's important. You now have an equation with one variable. And that's what you need. You need an equation with one variable. In one variable. Okay, so now we're going to solve. Step 3 says to solve. So notice step 3. Step 3 says solve the equation containing the one variable. So if I solve this, x plus 3x is 4x, equal 4. And remember, step 3 says to solve. So you can take this right here, and you're going to solve it. That's what you're doing. All right, and so I'm going to divide both sides by 4, and so I get my x value to be 1. All right, so far what I found is this. So far I found that the solution to the system, x has to equal 1. That's what I found. Solution, x equal 1. Now I've got to find the y value. So that was step 3. So step 4 says this, back substitute the value found in step 3. So I found the x value in step 3 to be 1. So I'm going to back substitute, and I'm going to go back into the original equation, right here. And it doesn't matter which one I use. Does not matter which one I use. But it's easier to use a 1 in which, use this one here because y was already by itself. I'm going to substitute the value x into that equation. So step 4 says this. I'm going to use either equation, does not matter which one. So I'm going to use y equals 3x. And in place of 3x, I'm going to substitute x equal 1. So y equals 3 times x is 1, so that's 3. So y is 3. So that's one of my solutions, and that's the other solution for x. Well, let me rephrase it. That's the y-coordinate of my solution, and that's the x-coordinate of my solution. And notice what I said. I said the y-coordinate, x-coordinate, because remember, when we graphed these in the previous lesson, the solutions were ordered pair. The solutions is an ordered pair. So on the worksheet where I have solution here, you have to put it as an ordered pair. If it says put as an ordered pair, you need to put it as an ordered pair. So ordered pair, remember, ordered pair, x comma y. So x here is 1, y is 3. All right, now, if it doesn't indicate to rise in ordered pair, then you can say, but you got to say this, you got to say x equal 1. Don't just say 1, 3, because that's not correct, unless you put it in parentheses like this, because that represents an ordered pair. And then y equal 3. All right, so, and then step 5 basically says, check your proposed solutions in both of the equations. But you could have messed up. Somewhere around here, somewhere around this process, all this process, you could have messed up. You could have did an error, and these would not be correct. So that's why they're saying, just go ahead and check. Now, you don't have to check. That's not requirement. These are the ones that are required to get the x and the y, but you do not have to check. But it is a good idea to check. So go back to the original. Go back to your system. You must go back to your system. So my system is x plus y equal 4, and then y equals 3x. So basically in place of these x and y's, you're going to plug in the values. So x is 1, y is 3. So here we go. So the question is 3 plus y, I'm sorry, x is 1. X is 1. 1 plus y, which is 3, the same thing as 4? The answer is yes. The next one is y, which is 3, the same thing as 3 times 1? The answer is yes. All right, so that's your solution. All right, so that was step 1. I mean, that was number 1. Okay, number 2. All right, number 2, let's look at this. We have this system, negative 3x minus 4y equal negative 2, and then y equals 2x minus 5. So again, step one is to choose one of these equations and get a variable by itself. So you need to be efficient. You need to think efficiency. What's the best way to do this? So don't choose the first equation, because if you say I'm going to choose the first equation and divide and get x by itself, at some point you're going to have to divide by -3, and then you're going to have some fractions, and then you don't want to deal with fraction. It makes things a whole lot complicated. Same thing here. If you want to get y by itself, don't do that, because at some point you'd have to divide by -4. So over here, I would not choose the first equation. So think strategically. So look at your equations, and then in number 2, the y value is already by itself, so that's the one you're going to use. It's no brainer. Use this one. All right. So in step 1, I'm going to use this equation: y equals 2x minus 5. Okay, so that's step 1. All right, step 2 says this. Step 2 says substitute the expression found in step 1 into the other equation. So here's what I got. Here's what y equals. So whatever is by itself. There are going to be some problems where x will be by itself, but y is by itself, and you're going to substitute this into the other equation. So if you need to draw it, you draw it. The other equation, and remember you solve for y. So in place of this y, you're going to substitute 2x minus 5. So if you need to underline this expression that's on the right hand side, underline it, and because that's the one that you're going to substitute into y, into the other equation. So here's what you get. You get -3x minus 4 times y. Now remember, y is not a monomial, so y is more than one term, so you got to put that in parentheses. So 2x minus 5. So notice, -3x, read it above, -3x minus 4 times y, see this y, which is now this, equals -2. So now you have an equation that just has the variable x, and then you just solve this equation based on your previous knowledge from other courses. So to solve for x, you got to get rid of the parentheses, so you can distribute the -4. And so I get -3x. -4 times 2x is a -8x. -4 times a -5 is a +20. And that's going to equal -2. So this is now step 3, by the way. Step 3. So step 3 says to solve. So that's what I'm doing. I'm solving this equation. That's what I'm doing. Combining like terms, a -3x and -8x is a -11x plus 20 equal -2. And subtracting 20 from both sides. So notice I'm solving this linear equation. This is a linear equation I'm solving, so I'm getting all the variables one side, constant to the other. Combine like terms, I get -11x equal a -22. Dividing both sides by -11, just like this. That's how you can do the work. -11 divided by -11 is 1. 1 times x is x. And then -22 divided by -11 is a +2. Make sure you say +2. You have to know that a negative divided by negative is a positive, and you need to simplify this. 22 divided by 11 is 2. So I found, in terms of my solution, I found the x coordinate. So the x value is 2. All right, now I've got to find the y value, though. Remember, there's an x and a y, so you got to find the y value. So step 4 is where you're going to back substitute. That's what your book calls it, back substituting. So in place of x, you remember you're going to go back to your original equation, your original system, and you're going to pick one of those equations and you're going to substitute 2 for x. And again, be strategic. Which one do you want to substitute in? You want to substitute in the first one or the second one? Well, hopefully you're going to pick the second one, because that's the one in which y was already by itself. So it makes things a whole lot easier to use this one. So if you use, it doesn't matter, you can use this one, but you're going to have to at some point do this first, then bring this over, and then to get y by itself, you have to divide by -4. So it's a little bit more convoluted, a little bit more challenging to do that. Now you have to know how to do that, but be strategic. Think about what's the easiest way to do this. Okay, so step 4. All right, so step 4, you're going to back substitute. So you're going to go back to either one of those equations, and you're going to substitute x equal 2. So go back to this one. So I'm going to use y equals 2x minus 5. So you're going to substitute So you're going to substitute x equal 2. All right, so you can substitute x equal 2 into this. So I get y equals, so remember step 4 is to solve for y. That's basically what you're doing, solve for y. Or find y. Find y. Okay, that's what I'm doing in step 4. So y equals 2 times x. X is 2 minus 5. So that equals 4 minus 5, which is a negative 1. So my so solution x equal 2 and y equal negative 1. In terms of an ordered pair, in terms of an ordered pair, you would say x is 2, y is negative 1. Remember, an ordered pair, you got to use parentheses. There's a parenthesis involved when labeling points. So negative 2, comma, negative 1. All right, and then step 5 is where you go back to the original system and you check your answer, make sure it's correct. Because at any of these points, I could have made a mistake. And so I'm going to get, now here's my system, negative 3x minus 4y equal negative 2, y equals 2x minus 5. That was the system, so let's check it. So let's check. So in place of x, I'm going to plug in 2. In place of y, I'm going to plug in negative 1. So here we go. Negative 3 times x, which is 2, minus 4 times y, which is negative 1, equal negative 2. So I want to see if that's equal to negative 2. Well, this is a negative 6. This right here is a positive 4. And this whole thing is a negative 2, which is what I wanted. So far that one's correct. Now let's check the other one. So y, remember, x is 2, y is negative 1. So y, which is negative 1, equal, I want to see if that's equal, 2 times x, x is 2, minus 5. Well, 2 times 2 is 4, 4 minus 5, and that is a negative 1, which is what I wanted. All right, so this checks out. So that's your solution. All right, next one. Number 3. Suppose you had this system. Let's suppose you had, let's try this one. X minus 2y equal 3, and then 3x plus y equal negative 5. All right, so there's my system. I want to find the solution to this system. So I want to find what x and y will make these two equations true at the same time. All right, so step 1, remember step 1 says, solve either of the equations for one variable in terms of the other. So in other words, get y by itself or x by itself. Now, remember what we talked about. So if you choose the first equation and you say, I'm going to get y by itself, I would not do that, because to get y by itself at some point, you'd have to bring the x over, bring this term, so you subtract x on both sides, but then you would have to divide by negative 2. So you'd have fractions. You'd see you'd have 3 divided by negative 2 plus x divided by negative 2, and you don't want to deal with that. So if you're going to choose the first equation, which variable do you think you're going to pick? Well, you're going to pick the x, because that already has a coefficient of 1. If you want to pick the second equation, it doesn't matter, the first or the second, because either one's going to be fine, because in the second equation, notice that y has a coefficient of 1. So it does not matter which equation you choose, as long as if you choose the first, you solve for x. If you choose the second, you solve for y. You'll get the same answer in the end. Okay, so let's do this. So step 1, I'm going to choose the first equation. All right, so remember I'm solve for x. So I'm going to choose the first equation and solve for x. So here's my equation. We're just going to go ahead and rewrite it. And we'll get x by itself. So I'm going to add 2y to both sides. That's what you're doing. Combine like terms. So I get x equal 2y plus 3. All right, so that's what I get. All right. Now, let me go ahead and do this just to show you. Again, it does not matter which one you use. Okay. So someone else in step 1 could have picked the second equation. It does not matter. So step 1 is where someone else could have said, I'm going to solve for y instead in the second equation. So I'm going to choose this equation, 3x plus y equal negative 5. And so I'm going to get y by itself, so I'm going to subtract 3x on both sides. And combine like terms, I'm going to get y equals negative 3x minus 5. All right, so either one's going to work. So someone could do this right that I'm about to do, or someone could have done this. It does not matter in this case, because this equation, you had a coefficient of x to be 1. Here, the coefficient of y is 1. Does not matter. Okay, so let's continue with step 2 now for both of those. Step 2. So step 2 says, I've got to take this expression here, and I go to the other equation. So remember, the other equation for this one is this, right here. And so in place of x, I'm going to substitute 2y plus 3. All right? So step 2. So I'm going to get 3, remember your parentheses, times, remember this is x, so x is 2y plus 3, equal negative 5. Oops, I'm sorry, I forgot the plus 5. Let me redo this. So 3 times 2y plus 3 plus this y equal negative 5. So be careful. Make sure you're reading this correctly as you go through this. All right. And so if I okay, and then step 3 is to solve. I'm going to solve this equation. So that's step 3. So this equation here. So I get distributive property. I get 6y plus 9. 3 times 3 is 9. Plus y equal negative 5. Combining like terms, I get 7y plus 9 equal negative 5. Subtracting 9 from both sides, combining like terms, I get 7y equal a negative 14, and divided both sides by 7, I get y equals a negative 2. So there's my y values. So in terms of a solution, I just found that y equals a negative 2. All right, so I found y. Now step 4 is where you find x. Okay, step 4 is where you find x. Okay? All right, find x. All right, now listen carefully. So step 4, remember step 4 is where you back substitute. So that says you go back to one of your original equations, and wherever you see the variable y, you're going to plug in negative 2. Now listen carefully. You can go back to step 1. See right here? Remember trying to find x, right? Well, step 1 is where we already had x by itself. We picked one equation, but here's the issue. You can do this, but you need to make sure you did not make a mistake here. All right, you need to make sure that this is not an error. So if you go back to, if you want to use step 1, to solve for x, to find out what x is, you can. So I'm going to use x equal, from step 1, 2y plus 3. All right, and so do I get x equal 2 times y is negative 2, plus 3. So that's equal negative 4 plus 3, which is a negative 1. Negative 1. So I found x to be negative 1. So there's my x coordinate. So in terms of an ordered pair, your solution would be, remember it's x, y. So x is negative 1, y is negative 2. So again, remember what I just said. In step 4, when you want to find the other variable, remember step 4 is where you back substitute into one of the equations in the system. You can go ahead and use step 1 as long as you are certain, that you did not make an error anywhere in this process. Okay. And so step 5 is where you would check your solution. So step 5, if you want to. On a test, you may not have time to do this, but you go back to the system. So step 5 is where you check. So you have x minus 2y equal 3, 3x plus y equal negative 5. Alright, so let's check this. So let's check the first one, x minus 2y. So x minus 2y equal 3. So let's check that. So x is negative 1, so negative 1 minus 2 times y is negative 2. And I want to see if that's going to equal 3. That's the idea. So negative 1, a negative 2 times a negative 2 is a positive 4. And is that equal to 3? And the answer is yes. Okay, now let's check the other one. So that one's going to be 3x plus y equal negative 5. So in place of x, I plug in negative 1. In place of y, I plug in negative 2. So 3 times negative 1 plus a negative 2. And the question is that equal to a negative 5? That's the question. Well, that is a negative 3. So is a negative 3 plus a negative 2 equal to negative 5? The answer is yes. So that checks out. Okay, so remember, step 5, I'm not going to ask on the worksheet for you to check your solutions, but it's a good idea to do that because it's very easy to do. So don't turn in something that you had plenty of time to work on and your solution is not correct when you could have easily determined if that is really your solution. So go back and check. All right, let's do it. Let's finish this one here, and hopefully you'll see that we'll get the same answer. You will get the same answer. Hopefully I didn't make a mistake anywhere on the process, and apparently I did not, because this actually works. Okay, so you can see the difference between the two. So remember, step 1 here, I used the first equation, and I solved for x. Step 1 over here, I chose the second equation, and I solved for y. All right, so let's go back and do this. So this was step 1 for this process. Now step 2. Step 2 says I take this expression here and I go back to the other equation. So in this case, the other equation now is the top equation. So in place of y, I'm going to plug in negative 3x minus 5. So I get x minus 2 times y, which is negative 3x minus 5. Make sure you put that in parentheses. And that equals a 3. And now step 3 is where you solve. So step 3 is where you solve. Solve for x. So I get, I have to use a distributive property, so I get x, negative 2 times a negative 3x is a positive 6x, and negative 2 times a negative 5 is a positive 10, equal 3. 6x plus x is 7x, plus 10 equals 3. Subtract 10 from both sides, so notice I'm solving this linear equation. So bring all the variables to one side, constants to the other. Combine like terms, I get 0, so 7x equal a negative, let's see, that I made an error somewhere, I think. So, I'm fine. Okay, so that's going to equal negative 7. So divide both sides by 7, I get x to be negative 1. And remember, that's what you wanted here. Remember, x was negative 1. All right? So now step 4 is where you're now going to solve for y. So that's what you want to do now, solve for y. Okay, so remember, step 4 is where you back substitute. You go back and in place of x, you plug in negative 1 into one of these equations. But again, we talked about, you can go back to step 1 to do this, as long as you're certain that this is correct. You didn't make an error here. So we're going to use y equals negative 3x, y equals negative 3x minus 5 from step 1. Alright, so in place of x, I'm going to plug in negative 1. So I get y equals negative 3 times negative 1 minus 5. Negative 3 times a negative 1 is a positive 3. And 3 minus 5 is a negative 2. So we found the y value. So my solution, depending on what the direction says, your solution, you could say x equal negative 1, comma, y equal negative 2. Now you got to say x equal negative 1 and y equal negative 2. So you have an ordered pair. So one's an x, one's a y. Or your ordered pair, if you write as an ordered pair, you got to put parentheses. Your x coordinate must be listed first. and your y coordinate must be listed second. All right, so that's number 3. All right, number 4. All right, suppose we had this system. Let's suppose we had 3x plus 2y equal 10, and then 2x minus y equal 9. All right, now notice the system. So step 1, I got to look at these two equations and determine which one I'm going to use. So again, I would not use the first one because at some point I have to divide by 3. I'd end up with fractions. I would divide by 2. I'd have some fractions in there. In the second equation, I would not choose x because at some point I'd have to divide by 2. And notice I'll have some fractions in there. 9 halves would be one of them. So you want to solve for y because even though that's not a positive, I still have a coefficient. There's still a 1 here, albeit a negative 1, but you see a 1. Okay, so I'm going to choose the second equation. So step 1, I'm going to use this equation, 2x minus y equal 9. I'm going to solve for y. So that's going to be the idea. All right, now think about, be strategic. So the more efficient way to do this is to actually add y to both sides. So add y to both sides, because if you add y to both sides, it now becomes a positive y. So you can leave it on this side and subtract 2x and then divide everything by negative 1. So I'm going to show you it does not matter. But think about this strategically. So think strategically. So there are 2 ways you can solve for y. So one way is to add y to both sides. Let me go ahead and do this here. Think strategic. All right, so one way, the best way, this is the best way. Take that equation right here that you just found, or that you're using, and add y to both sides. That's a y. And so the combined like terms, I get 2x equal y plus 9. And now subtract 9. And so I get y equals 2x minus 9. So you solve for y. So y equals 2x minus 9. Okay, now if you did this, or someone else could have done this, but again, you got to be careful. Someone could have said, well, I'm going to leave y on this side, so I'm going to subtract 2x from both sides. That's fine. There's no issue there. Mathematically, it's correct. What you do one side, you do the other. Combined like terms, it's a 0, which is what you wanted. But be careful, that's not a y, that's a negative y. So you got to make sure you write that down. Negative y equals negative 2x plus 9. That's what you have here. Negative 2x plus 9. But remember, you're trying to get y by itself, so this is a negative 1y. So remember, that's a negative 1y. And so now what you got to do is divide both sides by negative 1. Divide both sides by negative 1. Negative 1 divided by negative 1 is 1. 1 times y is y. Equal, now you got to rewrite this. Negative 2x divided by negative 1 is a positive 2x. A positive 9 divided by negative 1. Remember, this becomes negative 2x divided by negative 1 plus 9 divided by negative 1. That's what that becomes. So negative 2x divided by negative 1 is a positive 2x. A positive 9 divided by negative 1 is a negative 9, which is what you had here. All right, so notice this is probably easier for you than this one was. Someone could have messed up here, so you got to be careful. All right, so I did step 1. Okay, step 2. So step 2 is where you substitute that expression you found into the other equation. All right, so in the other equation here, meaning the first equation. So in place of, and if you need to draw an arrow, you draw an arrow to help you. And underline this. Underline it if you need to. So in place of y, I'm going to substitute that expression here into y, into that other equation. All right? And so if you need to use the word other, use the word other. It does not matter. Just whatever is helpful to you. Okay, so step 2 is what I'm doing now. So I get this. I get 3x plus 2y. So remember, now y becomes this expression here, 2x minus 9, equal 10. And remember, make sure you put that in parentheses, because all of this right here, all of this y, this is what y is, has to be multiplied by 2. So parentheses are needed. Okay, step 3 is where we solve now. Step 3 is you solve. So you're going to solve this equation. So distribute the 2. I get 3x plus 2 times 2x is 4x. 2 times negative 9 is negative 18 equal 10. Combine like terms. 4x and 3x is 7x. Minus 18 equal 10. Adding 18 to both sides, I'm solving this linear equation. So you bring variables to one side, constants to the other. And so I get 7x equal 28. All right, 10 plus 18 is 28. Divide both sides by 7. The 7's divide out. You're left with 1 times x is x equal 4. So in terms of my solution, I found the x coordinate to be 4. Now I've got to find what y is, so we've got to find the y. So that's going to be step, put step 4 here. So it'll be step 4. So step 4, you got to find y. All right, remember what we did. So again, let's go back to our discussion. So step 4 is where you back substitute. So in other words, you're going to take this value for x, which is 4, and you're going to go back to your system, and where we see the x, you plug it in into one of these. It doesn't matter which one. And then you solve for y. But remember, we said this. We said you can go back to step 1 and use that expression you found for y. But remember, there are many errors, many places in which you could have messed up. So if that's what you choose, you got to make sure it's correct. So if you're not certain, then just go back to one of the originals, and then you would check your answer. So I'm going to go ahead and actually use step 1. So solve for step 4, find y. So I'm going to use from step 1, y equals 2x minus 9. So y equals 2 times x. X, remember, we found to be 4 minus 9. So that's 8 minus 9, which is a negative 1. 8 minus 9, which is a negative 1. So I found my y value. My y value is negative 1. Now notice there, see all these steps here. So there's many places in which you could have made an error. And on the worksheet for substitution, on the worksheet, the solutions are going to be integers. So I'm not going to make them any fractions. Now you can have fractions. Can you imagine just plugging, if x here was, let's say, 4/5, whatever it may be, you'd have to plug in 4/5. It wouldn't be that bad. You'd have to plug in 4/5 here, and then just use your calculator. So it wouldn't be that bad, but you really don't want to deal with fractions if you don't have to. But the ones in your worksheet should be integers. Okay, for substitution. All right, so let's check. Let's make sure this is correct. Don't turn something in when you had time to check it. So that's step 5. So step 5 is to check. All right. So let's check this. So we go back to the original. So here you have to go back to the original. So you have to rewrite this system over. So the system was this: 3x plus 2y equal 10. 2x minus y equal 9. So if these were fractions, checking would be a task. But it's doable because you do have access to a calculator, so you can easily check these. All right, so let's remember we're checking now. So in place of x, let's check the first one. So 3x plus 2y equal 10. So in place of x, I plug in 4. In place of y, I plug in negative 1. So 3 times 4 plus 2 times negative 1, and I want to see if that's going to equal 10. Well, that's 12. That's negative 2, and that does equal 10, because 12 minus 2 is 10. Okay, let's do the next one. So let's do this one. 2x minus y equal 9. So let's check that one. So in place of x, I plug in 4. In place of y, I plug in negative 1. So 2 times 4 minus y. Now be careful, that's a negative 1. So notice what I put that in parentheses. You're subtracting y, which is a negative 1. And I want to see if that's going to equal 9. Well, 2 times 4 is 8. Subtracting a negative 1, same thing as adding the opposite. So I'm adding a positive 1, and that does equal 9. A plus 1 is 9. So that is your solution. So x equal 4, comma, y equal negative 1. And now as an ordered pair, so if you asterize an ordered pair, you would say in parentheses, remember ordered pair, so x, y, x first, y second. So you'd say 4, comma, negative 1 parentheses. All right, so that was number 4. Okay, let's do one more with this. So let's do this one. So number 5, let's suppose we had x minus 2y equal 15, 2x plus 3y equal 2. All right, so again, be strategic. Which equation do you think you would choose? Think about that. So which of those equations in step 1 you would choose first? So hopefully you set the first one, not the second, because the coefficients here are not 1. So you choose the second, and if you choose the first one, the top one, and in the top one, which variable would you solve for? Hopefully you said x, because that coefficient is 1. All right, so we're going to use x minus 2y equal 15. I'm going to solve for x. So I'm going to add 2y to both sides, and then negative 2y plus 2y is 0, so I get x to be 2y plus 15. So that was step 1. Okay, step 2 is where you're going to where you're going to take this expression here, and in place of x into the other. So remember, this is now my other equation. And in place of x, which is here, you're going to substitute 2y plus 15. So I get 2 times x, make sure you put that in parentheses because all of this has to be multiplied by 2. So 2 times 2y plus 15 plus 3y has to equal 2. And then step 3, remember, is where you solve that equation. So you solve for x. I'm sorry, not x, this is y, excuse me. So solve for y. So there's your variable y. Alright, so if I solve for y, let me make this see, this is y. Alright, so if I solve for y, distribute, I get 4y plus 2 times 15 is 30, plus 3y equal 2. Combined like terms, 4y and 3y is 7y, plus 30 equal 2. Now remember, this is a linear equation, so I'm going to bring all variables to one side, constants to the other. So I'm going to subtract 30 from both sides, and combine like terms, I get 7y equal a negative 28. 2 and a negative 30 is a negative 28. To get y by itself, right now I'm multiplying by 7. The opposite of multiplying by 7 is to divide by 7. But what I do to one side, I do to the other. 7 divided by 7 is 1. 1 times y is y. A negative divided by a positive is a negative. 28 divided by 7 is 4. So there's my y value. So the y coordinate of my solution is negative 4. Alright, now so that was step 3. Now let's go to step 4. Let's find step 4. So step 4 now, I know my y, so step 4 is you got to find x. So you got to find x. Now remember, find x. Okay, so this is the one where you back substitute. Now, you should go back to, mathematically, you would go back to one of these equations in your system, and in place of y, you would plug in negative 4. But if you're certain that what you have here, you didn't make a mistake, you can go ahead and use this. So I'm going to go ahead and use, from step 1, I'm going to go ahead and use this equation here, x equal 2y plus 15. And so remember, you're solving for x, so x is this. So all I got to do is, in place of y, I just got to plug in negative 4 in place of y. So x equal 2 times y, which is negative 4, plus 15. So that's equal negative 8 plus 15. And so therefore x equal a positive 7. So x equals a positive 7. So your solution, you would say x equals 7, comma, y equal negative 4. So you must say x equal, you must say y equal. As an ordered pair, if you ask to write the solution as an ordered pair, remember, it's actually a point. X goes first, y goes second, so 7 comma negative 4. All right, let's check it because I could have made a mistake anywhere. So let's just check it. So step 5 is to check. So go back to the original, though. You must go back to your system. There's no other way. So x minus 2y equal 15. 2x plus 3y equal 2. So in place of x, you'll plug in 7. In place of y, you plug in negative 4. So let's do this one first. So it's x minus 2y equal 15. So x is 7 minus 2 times y, which is negative 4. And the question is that equal to a 15? Well, 7, a negative 2 times a negative 4 is a positive 8. And yes, 7 plus 8 does equal 15. Now let's do this one. 2x plus 3y equal 2. So in place of x, I plug in 7. In place of y, I plug in negative 4. So I get 2 times x, which is 7, plus 3 times y, which is negative 4. And the question is that equal to a 2? Well, let's see. 2 times 7 is 14. And positive 3 times a negative 4 is a negative 12. And 14 minus 12 is a 2. So that does check out. So that's your solution. Okay, so that's going to take care of the lesson on how to solve a system of linear equations by substitution. So make sure as you go through your work that you're actually using these steps. You have these steps in front of you. So the more you look at them, the easier it is to remember.